I'm Lisa Bailey.
And I'm Patrick Bailey with IQlist.com. Today is May 1st, 2018, and this is a Manipulative Monday. Okay, before we get into the request for the week, the challenge, my wife was at Monday school. Now, this might sound kind of funny because we homeschool, but the school district here in Aurora, Colorado, they have some supplement schools for the homeschoolers. So we have there's actually a couple. The one we go to, they have a Monday school and a Friday school where they have some supplement classes. So if you mainly homeschool, you can bring your kids there on a Friday, and they have some classes for them, like Spanish or math. So they kind of supplement things that help you out. Now, for everything they teach, we don't use it so much as a supplement, but as more interaction.
No, I use it as a supplement because I'm not very good with art.
Okay, art. Okay, yeah.
And it's nice to have a science lab. And it's nice to have somebody speak Spanish to them.
That's true.
And so it's totally a supplement on the subjects that I'm probably a little lacking in.
And there's actually other schools that supplement the other way. So some people are bad at math, and so they are good at art, and so they bring their kids to that Friday school for math or something.
And I think every one of them kind of teaches their own subjects. So you can look into them and find out what one teaches compared to the other.
But also for us, it's a nice time to talk to other homeschool parents, especially you. Especially we talk to a couple of people on Monday or on Friday. And so we only go one day a week. We used to go on Monday, and this year we're going on Friday, so we kind of swapped. But you went to go talk to some people on Monday school that you haven't seen in a while, and you got to be my evangelist to talk about 3D printing in the homeschool, because that's what I'm pushing for. And so we brought some of those, the number places that we made. I've made some new versions that are smaller, and we brought them some samples, and they kind of went gaga over them. So, and they had a bunch of settings. Yeah. So they said a lot of stuff.
So these moms, I'm still really good friends with, even though my kids have transferred over to the Friday classes, the classes on Friday. I'm still really good friends with the moms from the classes on Monday, because they went to that the year before. And so I still hang out with them every once in a while. And I knew that a couple of the moms there had what I would call littles, primary children, preschool, kindergarten, first, possibly second graders. And so we brought them a sample of some of the work that we had done for the primary grades, the preschool and primary grades. And I just wanted to give it to them and, let your kids play with these and let them know what they think. And that started a conversation. Well, why? What are these? Where'd you get these? And I explained what they were. And I explained that my husband has created a new passion in his life to get a 3D printer in every, especially homeschool household, if not every household. And so they started to inquire and ask more questions, and they asked about the tiles, and I said, well, that was like a challenge that I gave my husband about, my children had a hard time with place value, and so he created those tiles, and he's created some shapes, and so they just started,
spewing forth ideas. Yeah, okay.
Spewing ideas.
I wasn't there.
Well, what about this? And what about this? And what about this? And I said, awesome. Go to his website on YouTube. Go to YouTube, IQlist.com. Start typing in the ideas to him, because he really would like the primary educator in the homeschool environment communicating what are some of the manipulatives that they would like to see created with a 3D printer. And so we just kept chit-chatting, and they just kept all through the whole 2 hours that I hung out with them. Just every once in a while, they would be like, a puzzle for this, and the inner ear, and so it was really kind of cool. So that's what happened.
Yeah. So go talk to some homeschool moms. Most homeschools are run by the mom. I don't say that. That's just the kind of way it is. Probably 80-90% are run by moms. So that you got to focus on what they want and what they need. And you had a conversation with a group a week ago, and some of the things, engineers have a problem with this. I have a problem with this. We think through ourselves. And so we go, this is what I would want, so isn't that what you would want? And so I don't have all the details in front of me, but it's interesting the questions that came up, that they talked about. So you don't know what you assume what they want, and it's a total different. I'm glad I wasn't there because I don't want to influence them. I just want to get the feedback. What in the world are their questions and different things? Well, how much do they cost? Like one person was like, the other day I gave one of the homeschool moms some stuff. I gave her son some stuff, and she's like, "Oh, this is cool." It's like, "Oh, do you get? How do you do this? Do they just go buy plastic sheets and you melt them?" And I was like, "No, you get these little tubes and you feed them in." Oh, another person was like, "Oh, doesn't it cost like tons and tons of money to print this out?" It's like, "No, this thing was $1." And they're like, "Oh."
Well, one of them asked, don't they come in pellets?
Pellets.
Yeah.
Someday they might, but right now they don't.
Or maybe some do, but I haven't seen those. Maybe those are the big, huge commercial,
I'm not.
But I've only seen the filament.
Yeah.
Anyway.
So it was interesting. So that's a lot of our focus. So I was really interested to get some feedback from those guys and see that they're excited and trying to figure out what they want. So anyway.
And that's kind of the whole purpose of this.
That's the whole
to
purpose
get some interaction and get this conversation going. Yeah. And it doesn't have to just be the homeschool environment. It can be a normal school.
Yeah.
So, a kid comes home and from a public school schedule and hears from his teacher that he's having a hard time with multiplication.
Yeah.
Well, and mom's pulling out, teachers pulling out worksheets and songs, and it's not working. And, what else could you create to help them out? So it doesn't have to just be homeschool. It can be any educational environment.
That brings up an interesting point. Like a lot of teachers, if they see a kid with a problem, oh, here, use this resource and use this resource and use this website. They give all the suggestions and the kid goes home, right? And it's too early to do this. But if all of a sudden 20% or 25% of the houses have a 3D printer, cool. Now those teachers, and we're away from that, but now those teachers can go, oh, Joey's having a problem with this. Here's the thing at Thingiverse to go print out that might help him, or here's the 5 different things, and some of those things are there right now, but there's not enough printers out there. People don't have them in their home, but all of a sudden if there's 20-25%, then the teachers could start suggesting that. Just like, when we were kids.
Well, just like they suggest apps.
Yeah, no one, especially when we were in high school, there weren't that many computers around, so they couldn't go, oh, well, just go on America. Go to America Online.
AOL.com.
Go to AOL and go to this place, or go to this,
Never.
Or even, in college when the web started to come out. Even when the web came out, you couldn't go, as a teacher, like in, 95, you couldn't go, hey, go to this website, because no one had computers. But you fast forward 10 years, and now they do, and so now they can say, go to this website, right? Yeah. I'm just bringing an analogy up, because at some point...
And they use they use apps, they use iPads, they use technology to help supplement some of the holes.
Yeah.
Some of the blanks in their learning. And so this would just be another way to help with that.
But it'll change the equation. So like a forward-looking teacher who's into 3D printing, they could say, more and more of the schools have a 3D printer. So they could say, hey, Billy or Cindy, here's this thing that can help you learn your multiplication table. Go to the library and have them print it out for you. That would be a forward-looking teacher right now. But to hand that out to a kid and say, hey, go home and print this, they'd be like, no one has a printer. That's kind of arrogant. But in 10 years?
I don't know.
Anyway. Enough of going off on a tangent. But I just thought that was cool, because that's what we're aiming for. We want to...
open up communication.
Yeah.
Open up ideas.
And get prepared for what's coming, because I think the homeschoolers can be a big inroads into this, because I can't speak for all the homeschoolers, but a lot more homeschoolers are more willing to spend a lot more money on their education on average, because they're already homeschooling. So they're buying the computer, they're doing this, they're doing that. And so dropping $1,000 on a 3D printer when they can see all the benefits.
Or maybe
as part of their curriculum.
Maybe a co-op.
Or a co-op, yeah. Or getting the schools to buy one or two and getting people in there to use them versus just, oh yeah, we throw one in the library and no one uses it.
Or it's always broken.
I don't know. I mean, I don't know how libraries are working right now. I just know some people who have them in libraries. I haven't really seen. Anyway, enough of all that. So, for this week, what is the challenge that you have for me this week? We talked a little bit about it, but I need to get more clear in my head.
I would like something very simple.
Simple. I can do simple.
I would like mathematical.
So Finn.
No. I would like numbers. I would like not just, one set of numbers. I would like, many sets of numbers so that I can't, I don't just have to do the number 9. I can maybe do 862.892. You always just have that one set of numbers that's 0 to 9, so you can't really repeat.
Yeah.
Be nice to be able to repeat numbers. So it'd be nice to have a couple sets of numbers. I would like the things that you would come across when you do equations in mathematics.
So like equals.
Multiple sign or multiplication sign, equal sign, addition, subtraction. Let's think higher up. Decimal point. Brackets. Parentheses. A repeating bar. A bar that shows that this number repeats.
Oh, yeah.
Little numbers for exponents.
That you can't swallow, right? Well, I guess it depends on how old your kid is.
True.
Right? But you just want these physical objects so you can just arrange them, right?
Yeah, so if, for example, our daughter is working on multiplication right now. Wouldn't it be great if you guys could sit across from each other like a chess game? And you have all these numbers down on the table, and you just start grabbing, 9 times 2 equals, and she grabs 1.
And she has to figure it out. Okay.
It's just, once again, another hands-on way, another type of tool that you can use. My son is learning exponents. I could do 4 to the 5th power. The little 5. So what does that look like? Well, that looks like 4 times 4 times 4 times 4 times 4 times 4. Equal sign with an answer.
Okay.
It's just another way.
Another visual tool.
Now, I know you can buy these sets. They're out there. We all have had them on our refrigerators.
Yeah.
But it'd be nice to see what you can create on the 3D printer as far as the things that don't usually come with those sets. And that usually includes the higher thinking parts of the equation. You can print out multiple numbers. So you don't just have to buy 1, 2, or 1 or 2 sets. You can print out as many as you want with all the signs and doohickeys that makes mathematical.
Okay, so that's the challenge, and so I'm going to go, well, in this case, I think this is more akin to some of the last challenge we had, so I might go into Tinkercad. It sounds like something you just want to make yourself. Because you might, there's not going to be a complete set, because what if you want, like, .333 repeating with a bar over it?
You got it.
But someone else wants .777, so...
Or maybe you want an arrow to show where you need to round. This is where you need to look to see if you need to round up or down, and this number gets affected. You can replace that number with... Anyway, sorry.
Yeah, I think it'd be interactive, too. So sometimes you might want to just print a bunch of sets of numbers out to play with. But also, you might have a kid who's having an issue with division. So you could actually print out with them in Tinkercad 3 divided by 4 and draw the whole thing out and have them actually maybe even solve it in Tinkercad and then print it so it solves in their head. I don't know. There's some ideas. But I think it's one of those things, there's so many possibilities, so to make a set is insane because it's like infinite. But to show people how they can make what they want, that maybe want to go. maybe the route I want to go. But other people might have some other ideas out there. So if you want to take up this challenge and figure something out, that'd be great. But also, I'm actually going to abuse this challenge because I also found this other cool thing I've been dying to print. And I'll show that in a bit. But it has to do with numbers, but it's really cool. And I'll print it out too with this challenge because I think it's awesome.
I think it's pretty cool too.
And
I've been asking you to print it.
I know. I'm looking at it right now on another screen. It's really cool. But I'll show that. Okay. So with that, I'll...
Challenge away.
Challenge away. Okay, now first thing I'm going to do is I'm going to use this challenge as an excuse to actually print this thing out, which I think fulfills part of this challenge, getting people to touch the numbers. I've been staring at this for like a month. I just haven't gotten around to printing it. So this looks cool. This thing happens to be on Thingiverse, it's thing 452651. And it just looks cool that you can do 9, you can twist it and do 9 times 8 equals 72. So you can challenge your kids with it. You can change the numbers and have them solve it. It just looks cool. But I'm actually not going to use this one. I'm going to use one of the remixes. A slight remix, because what this actually needs, if you look at the stuff here, is it needs a PVC pipe, which I have one downstairs, but I think it'd be a little bit better just to print the whole thing out with 3D printing. And it looks like one of the remixes actually did that. So if you go on this guy, Paulo Blank, if you go to this thing, you can actually click on remixes down here, which I already did. And you can see people who have taken this and remixed it in new ways. And there's a couple really cool designs here. In fact, I really like this one, except for he made the numbers too small. So I'm going to go with this one by Seb Fisto. And all he did was he added in just basically the PVC pipe. So I am going to go here, go to Thing Files, and this guy's, his remix happens to be thing 462389. So let me go down here and download all these. I don't need this .123dx, I just need the rest of them. So I will just click one by one and download them all. There we go. And so I've got them all in my download file here. And then if I look back on the picture here, I like what they did, where they have 2 different colors. Or he did here, where the numbers are all the same color and the times and equals and the tube and whatnot are all different colors. So I kind of want to repeat that. So let me bring up my Prusa control. And let me get, all I got are the numbers. So I'll take let's see what numbers we have here. Spin blank 1. That guy? There we go, there's the number. So I'll do copy paste, and I'll get 4 of these on here. Oh, come on, don't be a bugger. Just thinking. Come on. I need 4. Let me look at the picture again. 1, 2, 3, 4. Yep, 4. It's going a little slow right now. Okay, and I'll hit... I can just do these probably fast because they're kind of blocky. I think it's fine. And standard infill is fine. And I'll just hit generate. Slowly but surely. Okay, let's see how that does as it gets to the end. I think this is going to be fun. There we go. So I'm going to do a little double check here. How do you look? Looking good. And there's all my numbers. Okay, let me save that G code. And I will save it off to my downloads for now. So there's those 4. And let me go back and wipe these guys out. And then all the rest will be in another color. So let me see. So that's the 4x. So let me just drop everything else in here. Drop that. Drop that. Drop that guy. And my tube. That should be interesting. Okay, I'll leave that tube there in the center. We'll see how... I've printed something out like that before, and it actually worked really well. You know, I'm tempted to print this out by itself. It's a little bit of a weird guy. Nah, we'll give it all. We'll just put all these together. I'll just arrange them. But in this case, I want to use brims because I'm afraid this one's not going to hold on too well. The rest will. But that one, probably not so much. Let me click generate and then stare at how well these do. I don't know how this little knurled thing's going to do with the 0.2 millimeter height. We'll see. It might just end up being a little bumpy or something. All right. There we go. Okay, let me save this G code off and go print this guy out and see how well it works. Should be awesome, I think. Okay, this math spinner. So first, going over the numbers. This math spinner, which I did in 2 parts, in total took 11 hours and 8 minutes to print. It took 9.1 cents with electricity, and it weighs 0.108 kilograms. And at $20 per kilogram for a roll, it's $2.16. So the total cost to print this out with the tube is $2.25. And so we're going to check it out. And I'm liking it, but I'm also a little disappointed. So I really like these gears. I mean, I like the size of them. Mm-hmm. I like the numbers. I like the fact that you got that and you got the, let's see if I can show the equals. There we go, equal sign. I can show it. I really like it. But I printed out this tube, and I thought it was mistaken because it's too small. So here is one of the end, which I actually should have printed 2 end caps. I accidentally printed 1. So technically this print would be another 10 cents more or something. But if you look at this, it's too small. So there's too much wiggle. I don't know if I can show that really well. You know, I thought they would. I looked at this and another remix somebody did. Somebody actually made a remix where it's supposed to click. But they made the letters teeny, which is dumb, so I didn't print that one. Otherwise, I totally would have printed that one. But then I thought this was small, so I went to the store to see if I could get the right PVC pipes. I thought, oh, they just messed up. This is small. No, this is the right size. So I don't know if I screwed up the print, but I downloaded this guy's files and I printed them, and they're just that's way too loose. So, I mean, I can sit here, I don't know, I guess I could put these ends on and glue them, and then I could just set it on a table and rest it and do it, but that seems kind of lame.
Maybe even with the ends, little tension pushing in would maybe cause a little friction between the different pieces, but I don't know if that will...
Well, either way, yeah, this is just, there's no screw on this.
Yeah, there's no...
So I think this is begging for a redesign. So it would be nice to see how that guy... I don't have the time right now, but I'd like to figure out how to do a redesign on this. Because one thing, you could fix this tube. And so you could put the tube that has maybe screws in it. I haven't done screws yet, so that'd be interesting to do threads, and then have this with that threads in. And so if you had them thread on both sides, and has some tension,
that might work.
And that would probably work.
Yeah.
But it'd also be really nice. That's enough. I mean, if it was tension, maybe you make this tube a little bigger, and you make it, or maybe you don't. Maybe just the tension itself. Will pull it, and people can kind of move it, and they can adjust the tension themselves, maybe. So this is one of those designs that it's kind of begging for redesign. It'd be really nice if it could click. I'm not an expert enough on 3D design yet to figure that out, but I'd like to maybe in the next month or two, maybe come revisit this and try to figure out how to make something click, do some tests. I don't know. But I like the idea. I think this is really cool because you can, say 8 plus 0 and have your kid, figure it out. So, but right now, if I go 8 plus 0 and hand it to my kid, it just all is going to fall apart.
Well, and I noticed here there's a division sign, right?
Oh, there is? Yeah, division.
So you're going to need double digits over there.
Well, yeah, you can just print another one out.
Yeah.
Yeah, you're free to print one out. So you can start with this, and you could add more colors. You could add another thing. Yeah. It'd be nice to... Maybe that's why they didn't do it. I don't know. It'd be nice to do a redesign. Let's say the redesign with threads just worked. Mm-hmm. If you're going to do that, then you'd probably make a tube. You'd probably make a tube of several different lengths to put on Thingiverse. So one that's this size.
So as they learn, you can.
And then one that's bigger. One that's one that just keeps adding one on again and again.
You can do like 2-digit.
Yeah.
And then.
I think
1 digit and then 2 digit and 2 digit.
I think someone has a remix that has like 3 or 4 on each side because it's just adding more. I mean, you just print more of these. Yep. So I like it, but it's not done. Or else, well, I like to say that maybe I messed it up, but I don't think that I messed it up because this guy's STL files, and I'm kind of. There's a lot of designs on Thingiverse that are like 80% of the way there. Or 90% of the way there. This is like a real good concept.
It is.
But being loose, see, as a parent, ideally I'd like to go click, 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 9 plus 9, click, click, and it doesn't move. Yeah. And then hand it to my kid and say, answer this, figure it out.
Yeah, and it would move.
And then they could do it. But this, even if I put tension on it, tension might not be enough. It might be okay. But I prefer the clicking. I like it. What do you think? Sorry, I like
it, but yeah, it needs a little refinement.
It needs that extra 5%. And let me see if I can find. Let me show if I can find the remix that I really wish he had done. Here it is. There's this by Fun Boy. He did a remix, and if you look at this, he's got these little. Looks like it would click. I haven't printed it out.
Tension.
It's a really good idea, and he's got, it should in theory click. But if I was going to do this, I would do that and add the screws to it too, because you don't want it to come off, right? Yeah. So this maybe needs to be remixed off this guy's idea. But the problem is, like, this is beautiful, and then he has tiny baby letters.
Well, but maybe the baby letters are bigger than they appear.
Well, no, but look, these are huge. Yeah. I mean, look at that.
Those are nice. Those
are ideal.
Yeah.
This is big.
But I could deal with baby letters if the function was better.
Yeah, but I would say combine both these ideas. To figure out. It'd be nice to print this guy's out and see if it works. Yeah. And if it really clicked nicely, or you go find people have been having things that click for years, right? So maybe someone else has an idea you can go look up that clicks. Yeah. And then just refine it. So
he probably didn't pick the right colors there.
He didn't pick the right colors. No, they should be
bright colors.
Yeah, and it depends on who you're handing it to. We're handing it to young kids, and so bright colors. I like that color. Mm-hmm. Or I like someone did, I think, yellow and black. I like that too. Mm-hmm. Just the contrast. Yeah. So I was so excited about this, and now I'm excited. It's really good. I want to remix it or get if someone else can remix it or something. I don't know. It's 80-90% of the way there. It's really awesome.
So get on that.
I'll get on it. Give me a month, or maybe I just need to. I think the right way is to go all the way. Is to put screws on the end so you have that tension so these things don't fall off.
And you can add more layers.
And you could add, people could put bigger tubes in there. Mm-hmm. And then big numbers and get it to click. And I think that's the winning combination.
Yeah, I think you're right.
But he had the right idea. So 95% of the way there. Yep. Okay, so that's our opinion on that. So now on to the numbers we printed out. Okay, here I am in Tinkercad trying to make some numbers. So I think this is probably one of the simplest ways to do it because we don't need too much. I thought of 2 ways of doing this. One, I can go in here into basic shapes. And let me just make this one just numbers. And I'm not super keen on doing this one, but I'll do it anyway. So we can just make literally the number 1. Sans mono, sans. There's only so many options they have here. So sans serif, or sans. I like that one. Yeah, this is where Fusion 360, well, might be a better choice because you got more options for fonts. But, let's see. What can we do? Bevel. Okay, segments. Height. Nope, we don't need it very high at all. We go to the front. Let's see how big we want to make this. So, we'll make it a decent size. So I'll do 40 by 40. And maybe 35. 35 by 35. Ah, come on. Changing size on me. 35 by 35. There we go. Wish there were more choices for fonts. But we'll try this. So let me zoom out. Orthogonal view, top. And we'll just place a bunch of these in different places. So copy paste. We'll put a 2. Copy paste, do a 3. Let me make a bunch. Paste. I don't know. I'm kind of thinking it'd be nicer to do this in Fusion 360 because then I'd have more font options. But I think I'll stick with this for now. Because at least I get my numbers out and we'll see what my wife thinks. She might agree with me, or I'm not going to tell her. I'm not going to tell her. She might just like them the way they are. Okay, 0. So there's all of our numbers. Oh, why'd you gotta flip around me like that? Okay, they look fine. They're kind of tall enough. So I had a couple ideas. One, just to print out numbers just like this. In that case, I'll just leave it as is, hit export, everything, STL, and just download the entire thing. So we have all these numbers. Where are you? There you are. Okay. Numbers. And the other thing I always wanted to do is they might be... See, you might want a thicker font for this because I don't know how they're going to feel. But I think you can also do this other thing and give them a backing. So let me go click on here and say New Design. And let me make some tiles with these numbers on them. So let me go in here and drop a box. We'll make this, let's do 40 by 40. Go to the front, and we want this to be, we'll click on orthogonal view. Makes it easier for me to see. And drop it down to 2 millimeters. So 2 millimeters thick. And then I think I can do some radius stuff with this guy. Let me see. Oh, look at that. Ooh, I like that. Make a little radius to it. Okay, so now I've got a tile. Let me see what I can do. Let me go... spin it around a couple times. There we go. So now if I can take that, put it right there. Now put my text on top of that. So make that a 1. Make a different color so I can see it better. And let me see, sans? Nope. Do serif? Serif. Okay, so we'll place it on there, and we'll make it as big as we'll fit on that title. Where'd you go? It's not where I wanted to go. Back. There we go. Okay, let me click on that, make it... Oh, I can make it fat. Oh, that's a good idea. Let's make it... There we go. Let me look at the front. I don't want it that tall, so I just want it to barely stick out. Yeah, about 5 millimeters. Let's go with that. 5 millimeters. That should work. And so now for convenience, I'm going to take this and group it and do a copy paste so I can kind of get them all lined up the way I want. Where are you going? I think I'm hitting the back button. It's going back to the previous design. I guess. Okay, copy paste. I kind of like this idea better. Then you have these little discs you can use. Okay, now let me select all of this and ungroup. Wait, no, ungroup. And hopefully it doesn't move it too much. 4, 5, 6, 7, 8, 9. There we go. Well, not perfect, huh? I can use the arrow keys to nudge these over a little bit. And we'll see what Lisa thinks. 4 is not going to really fit on there very well, is it? Yeah, I need to take you in just a bit. Okay. So now let me copy and paste that because I forgot my 0. And 0. Need to nudge that one a little bit too, don't I? Quick pushing buttons. Okay. There we go. And so now I'm going to group these individually just so I don't get them unorganized again. Let's see. Yeah. Group. Yeah. Group. 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 Okay, I like that. Let me see. Yeah, so let me export that. Everything in the design as an STL. So I'll use that in a minute here. And then, let me see, can I copy that and put on a new design? Let me change the name here. Numbers, width, platters, I don't know, platter. Let me go click on that, say new design, because now I want to try to create all the rest, which a lot of the rest needs something underneath, like an equal sign. Can't just have 2 lines. They'll just, fade away. They need something. Oh, I can paste. Nice. I can paste between designs. Nice. Didn't know that. Okay, so let me just paste a bunch of these. And think about what things oops, no, don't do that. Let me copy paste 3 at a time. Let me see, what kind of things do I need? And let me just stick with 9. Okay, so let me select everything and ungroup. Okay, so I definitely need an equal sign. I want to move. Need a division. Probably need a division symbol. Percentage. Multiplication. Probably need a dot. A comma. She talked about using parens. Let's see, what else stuff do you need? Well, let me just go with these right now. So move that down. That is too big. But we can. Oh, there you go. Let me change the size of that. Oh no, wrong one. Dot, so I can do a dot just down the bottom. Well, as bottom as I can get. Parentheses. Let's see, what else were you missing? I wonder if we'll do special shapes. Let me say shift. Okay. I wonder if we'll do Unicode. Ooh. Unicode. I don't know, fraction. Let me see if it does Unicode. And I'll explain what I'm doing if it does. Oh, it does. For those who may be unfamiliar with what Unicode is how we do all our characters. And so you've got your A, B, C, D, divide, symbol, all this stuff. So plus you have a bunch of other Unicode characters. And so as long as this is using Unicode, I can dump Unicode in here. Now, this actually is Unicode. So this is not 3 symbols. This is not 1 divided by 2. This is a symbol itself that happens to say 1/2. And so if you go find a Unicode, the easiest way to do it is just copy and paste. So you can find some weird Unicode and print it. Oh, that's cool. Oh, I'm going to do a 1/10 as an example. Oh, see? There's the gotcha. There's the gotcha. So whatever font they're using, since Unicode is huge number. I mean, in fact, there's vast empty spaces of Unicode for future text that may exist. There's even an entire section on hieroglyphs and kanji and katakana and Chinese symbols and all kinds of stuff. And so when you make a font, there's no way to actually make a font that covers, well, I shouldn't say that. There are some fonts that cover just about every symbol, but not every font covers every symbol. So if it doesn't know what that symbol is, it'll just return like a question mark or some weird thing. So this obviously does not know what 1/10 is, what this number is. Let me see if it knows 5/8. It knew 1/2. It knows 5/8. Well, let me just do 1/2. Let me do 1/3. That's more interesting. Oh, it doesn't know 1/3. Okay. But it knows 5/8. But that could be just the font. Let me go do sans. No. Sans mono. No. Okay, doesn't know. We'll just stick with 1/2 for now. That also means we might be able to find some cool symbols. Let me go see what I can find. Okay, I think this is fine. So I'll go save the export this. I learned something new. That's totally cool. That is awesome. So let me go back here into proofs of control and dump some of these in here. Numbers. Yeah, that should print just fine, but she might like them. I'm more excited about having the discs. So let me generate those. And I got that 0.2 millimeter height because they don't need to be all that fancy and a standard infill. And yeah, there we go. Save that G-code off. And I'll leave it in the downloads folder for now. Let me go back and delete that. Let me get the... Oh, I didn't name these right. Okay, so there's all those numbers on the plates. I think she'll like these. I like them. Probably less breakable, too. A little more solid feeling. Looks good. Save that G-code. And I'll name this number with plates. I don't know. And then this guy. generate the G code. Looks good. Save that off. And I'll just say math symbols with platter. Okay, so I'll go print those off, but I might take a little time to explore and see if I can go find some other interesting Unicode, like maybe there's a division symbol or something in there that I can just easily print without having to design it. That's really cool to know that it can do Unicode, because there's all kinds of cool Unicode characters I can probably copy and it might just work. Anyway, we'll see. So let me go print those out. Okay, after reviewing part of the video I just made after the fact, I realized I didn't do it quite right. So what I want to do is kind of replicate what I saw in Tinkercad, where I actually had two colors, which even though I don't have a multicolored printer, there's an option where I can swap out the filament based on a layer. So the Prusa control gives me that ability. So let me show you how to do that in case you're unfamiliar with it, because this is what I actually did. So let me go, all I have to do is put your stuff in here, your STL file, in Prusa control, and hit generate. And then what you can do is you can start going up the layers. And what I want to do is I want to change the color right where it starts to actually do the number and no longer do the platter, which I believe is at 2 millimeters. So 2 millimeters, I think, is the last bit of the platter. And there we go. 2.2 is my number, the start of my numbers. I can go over here and click this plus button in Prusa control, which they call it a color change point. But I think we're calling it a swap point now, because you could use the same color, right? Just a different material. So now what it'll do is it's really cool. So if you do that and you save the G code, which I've already done prior, but here I put that swap point, and I can put multiple swap points if I want. But I would save the G code out. I'll just put it in the desktop for now. And I've already done this. But so what it has is a stop point. So what'll happen is it'll print along just fine. And then right when it starts the 2.2 layer, it'll stop, it'll pull the head up a little bit, go over to the side, and start beeping. And it has a little a helper menu there, which will help you to push the button to get the old filament out and to guide you to put the new filament in and load it, get it through, test it, and then push the button and it'll start printing right from where it stopped. So it's really cool where you can change colors, but it's per layer. So you're not going to get anything super fancy. But in something like this, where it makes perfect sense where you can change that color on that layer, it works really well. So I forgot to do that in the last video, so I want to make up for it. The last portion of this video. But anyway, so that's what I did, and that's how this is all going to work. And then from now, I've already got it all printed, so now let's go to showing this to my wife and see what she thinks about it. Okay, so our numbers that we printed out. So we printed out a couple different things. We printed out numbers and numbers on platters and some equations and extra things to go with it. So I just want to go over the numbers first. So the first thing with just the single numbers, just these little numbers like this, individual, took 3 hours and 47 minutes to print, 0 through 9. It took 2.9 cents with electricity. And it took, 0.022 kilograms. So that took 44 cents worth of filament. And so altogether, just to print 0 through 9, took 46 cents to print. Now the number platters.
No, hold on. Sorry. You go ahead.
I want to get the numbers out.
Get your data out.
Get the data out. And then for the number platters, which has a platter and the number on front of it, that took 3 hours and 59 minutes to print those out. It took 3.2 cents with electricity, and it weighs 0.048 kilograms altogether. So that's 96 cents worth of filament. Mm-hmm. And so to print 0 through 9 on these guys took 99 cents, which makes sense because I got the platter. And then for just the other ones that are just, random stuff we need, like equals and whatnot, I just made 9 of these. And so this took 3 hours and 15 minutes to print.
All 9 of them?
All 9 of them.
Mm-hmm.
It took 2.7 cents with electricity. They weighed altogether 0.036 kilograms, which comes out to 72 cents worth of filament based on $20 for a kilogram of filament. We're trying to figure out how to hold these up. And so the total cost on those was 77 cents.
That's for 9 of them.
For 9 of them, yeah. Which makes sense. They're a little bit cheaper because the other one was 9. These were 10.
9.
Okay. So.
There's an 8.
Trying to figure. I need to get a tray or something to show them off. A display.
Display.
I'll figure it out.
That's going to be your next manipulative.
My next manipulative. Make a display to show manipulatives. For videos, right?
Would that be ironic or coincidence?
Coincidence? Just fate. I don't know. So let's go one by one. So what do you think about just the numbers? So just the individual numbers.
They're okay. I mean, they're numbers.
The numbers.
They're fine.
Yeah,
they're small. They do their job. If I had to print out a bunch of them, like let's say I needed, 10 sets of 0 through 9, this would be the way that I would go. Because
they're tough enough.
They're tough.
Trying to see if I can break them, and I can't. Yeah, they're pretty.
We brought them downstairs, and our kids are kind of our guinea pigs. We bring them downstairs and see how the kids will react with them, and they just started to, put them in.
Okay.
Started to mess around with them, but that was about it with those.
Yeah, I'm not particularly fond of them. They're okay.
They do their job.
But I like the platter ones.
I like the platter ones too. I think if you are,
Got these platters.
If you are using these to help your child learn some mathematical skill, whether it's horizontal or vertical, it definitely helps stay more organized because you can line up the blocks. So I would choose these plates or the block more than the free-flowing number by itself.
And also, I didn't ask you this. I don't know if it's a big deal. Like the plate's about 2 millimeters, which I think it seems fine to me.
Yeah.
And then the lettering is 3 millimeters higher than that. I don't know if that's too high or just about right, or does it go lower?
Didn't even notice. It wasn't. Didn't even cross my mind. So it must not have been a problem.
I could probably make it 2 millimeters lower, which would save a little bit of filament, not much, but it'd probably get the same effect.
Mm-hmm. You should try one. See what it looks like.
But if lower works, if 2 millimeters lower works, even just 1 millimeter. Yeah, even 1 millimeter would probably get the effect. It would save a little bit of filament and print time, and get the same effect. But I do like the 2 millimeter. I think that's a good thickness for the plate.
They're stout. They're sturdy, and I think the plates are a better way to go because eventually you're going to need to print out, like he had showed, the equal sign, and that could be a little bit tricky to print out without some sort of background.
Yeah.
So I really like the plates, but we still have a problem with some other symbols that we were talking about.
Yeah, how do you do them? So some things make sense, like an equal sign, same size,
So if you have here, hold that up, honey.
Okay,
5. Oh, sorry, 5.
There's
we don't have a plus sign.
Oh, I didn't print a plus sign.
You didn't do a plus sign.
I didn't print a plus sign.
No,
well, that's pretty dumb.
You were all into division and multiplication.
Oh, I didn't make a plus sign.
You didn't.
Oops.
Okay, so let's do 20.
20
divided by, and this isn't exactly the divided by I wanted.
Okay.
I kind of wanted the. Anyway, you could, do it any way you want. So you can do 20 divided by
4.
4 equals.
Do I have a 5?
Of course we have a 5.
Dang it. No, I can't see it. Oh,
it's right there.
Okay, is that 20,
actually, something like that. But our hands are in the way. Stuff. But anyway, so first of all, the blocks, the plates keep everything nice and organized, as opposed to these free-floating letters. They could really start to, just like with other manipulatives, just kind of, float around and get unorganized. Yeah. So I like the plates. But yeah, we're going to have some problems with other things. I don't know how you would fix that. We kind of brainstormed some ideas.
We thought about some ideas. Now, one before I get into it, what about the font? Because in Tinkercad, we're limited to 3 fonts right now.
Okay.
And there's a reason behind that. Probably because those fonts, I'd have to go look up, but those fonts are probably open source or free or something, so they can do what they want. versus, on my computer, if I'm using Fusion 360, I have access to all the fonts on my computer.
So you could change the font.
So I could change the fonts.
Was this one of the ones that came with Tinkercad?
Yeah, Tinkercad has 3 fonts.
I think it's fine.
I think it's fine, but I think you could, there might be better fonts. I mean, it's okay. There's no problem with it, but there could be ones that are better.
But I definitely think if it's something that you don't like, you need to pick a font and stick with it. Don't start switching things up.
Yeah, that's true. Don't change your fonts.
Find one you like. If you don't like this, I think this is fine. Number's a number.
I fiddled with a bunch. I like the fact that it's Unicode, so I went and found a bunch of Unicode characters, which I'm sure works in Fusion 360 too.
Yeah.
I haven't tried, but it should, because it's just a font. But if the font happens to have that Unicode, it's kind of cool. You can just drop a Sigma in there. Or I found a Delta.
Can I tell you that was all he was excited about?
I got too excited. So I forgot to print a plus.
So I don't get a plus sign.
But you have pi.
And I don't get a subtraction sign. But
you have it's not equal to a sign.
But we got a percentage.
You got
an infinity.
And you got an integral. Right? Because you need that. But I just thought that was cool. But then one thing we were talking about is, for some things, how do you line them up? If you're doing with a kid, you got, 15 plus 4. But if you want to do like a square root, what's the best way to do that? So like I printed out a little square root, and you can stick that in front of there, but usually a square root goes over and has a bar above. And so it's kind of confusing to look at.
Or a division bar.
Yeah, or a division bar, take that out and do a division bar. So we've been thinking about that, and we were arguing about which way to go. I was kind of pushing for it. I don't know if I've sold you on the idea, is to have I like the idea of having the same size. Everything's the same size, except for now you have a second size, or weird sizes.
Where those fit in.
Up there, they fit in. So you make one that actually is behind. It's like a square root, and it goes up and over. And then it's got little holes or spacers where you can just put these in. Or maybe like a strip that you could put 5 or 6 in, and you just put them in there. So
what happens with a division sign, and it's long division, and you need to extend the line out? You have to print another one out. So you'd have to make one that's as long as you typically want, that maybe it can fit 4 in there or something. But then you might have, rather than all the numbers would be the same size, but then these extra ones would be all over the place. I think as you start to get up into the higher math, this becomes a lot more difficult. I think in the primary math with adding and subtracting 1, 2, 3-digit numbers, multiplication, memorizing multiplication, memorizing division. I think this is where this is good. Other than that, you're going to have to start customizing it to your needs. And that's the nice thing, is you can customize it. Yeah. Like we didn't do an Exponents. Yeah. Yes, so that was the debate. Like, to the second power, what do you do? Yeah. And I was kind of thinking you'd make a slightly bigger tile with it to the 2 second power, and you'd have a place for the tile to go in. Yeah. I don't know. Here's your decimal point. 6.2. So. No, I don't know. It's a debate. I think, once again, we need to put this in front of our guinea pigs. Yeah. Let's see what the kids do with all these things. Yeah, see what they do. I would be curious to print out another number set. They'll totally use Sigma. Did I do that backwards? Sigma. Sigma's awesome, right? I think we need to print out a few more number sets. And maybe an addition and subtraction. That might be important. And use these more for mental math. Adding and subtracting, multiplying, dividing with mental math. And then if you start to do your higher ups, you're just going to have to print out what you need. And this is one of those things, like we've been talking about. We're talking about, the 3D printing becoming a great equalizer to help kids out, because some kids, you start writing stuff in on pencil and they get it. They don't need this. They don't need this. At a certain point, they're not going to need this. Well, it depends on the kid. Yeah, some of these things I probably could have used when I was in calculus and stuff. It might have helped.
I think even in calculus, if you're in calculus, all of a sudden sometimes just some people learn better by touching.
Yeah. And even maybe if you're a tutor and you're going out and helping those kids fill in some of those holes that they have in their education as far as higher up mathematics. I could see a tutor taking a set of things like this to help them show the student that they're tutoring how to keep things organized and do stuff.
So, now that we've done all this, we have all these little things with integrals, which are very important, and derivatives, and square root.
Kendall's going to look at that and say that S font is horrible. That's what she's going to say. You know that.
I have a lambda somewhere.
She's not going to like that. This E is all messed up. Oh, actually, that way it's not. Wow.
Well, anyway. So what do you think?
Well, I definitely like the plates over the loose. I would choose that. Some people might like just the loose numbers over the plates. But I would probably just use this for mental math in the primary grades until we can figure out how you would use this in the secondary and upper mathematical classes. Okay. So it's okay. You did good. I'll give you a B minus.
B minus?
Yep, because first of all, you didn't give me a plus sign or a subtraction.
Wow, there's that.
And your multiplication kind of looks like a Roman numeral. So
that's true.
I'll give you a B minus on this.
B minus. Yeah, take what I can get. Anyway, so that's what it is. So if anyone else takes up this challenge or tweaks it or fixes it or finds a better way to do this, just post it, show it. We'll highlight it in the next video if someone has something. Because I like this idea of helping kids. This is more focused on, I don't know what age group, 5 to 12? Even though it can go higher? I don't know.
Well, it depends on the learning level of the student, so.
Yeah, you could go to 18, but people who need that tactile. When you're younger, more kids need that tactile, I think. As you get older, it might reduce. I don't know. But anyway, it's better to get different people learn different ways. And some people learn tactile. So if someone makes something up or figures out our problem trying to, how do we do the second power? Which is
how do we do exponents? How do we do long division?
Do I make bigger tiles? Or we have some ideas, and we'll probably try them out. But if someone has a better idea, or do you just... you have a 3D printer, so if you want to go do square root of 47, just go make a giant tile that says square root of 47. Maybe that's what you do. But, I don't know, it seems...
like it's not adaptable very easily.
Yeah, it seems not adaptable.
For the situation. So, okay.
Okay, well, that be that. Hey, if you liked the video, please give it a thumbs up. If you didn't, hey, give it a thumbs down. Also, if you like what we're doing here, subscribe to the channel by clicking the subscribe button. And lastly, have a piece of info to share? Just post a comment.